Hello, my dear students. This is Raman Rana here, mathematics teacher, Cambridge International School, Dasua. Today, we will first recapitulate the introduction of chapter 12. Then we move forward with the area of sector and segment. And at the end, we will revise PT1 syllabus, that is chapter number 10, circle. Let us recapitulate what we have discussed yesterday. Many objects are circular in shape. In day-to-day life, so many objects from wheels, flower beds, circular paths, dartboard, so many examples we have discussed. So it is very important to learn how to find the perimeter and area of a circle. We have also learned in the lower classes that the circumference of a circle is equal to 2 pi r and area is equal to pi r square. So area is equal to pi r square. Pi is a Greek alphabet. It is a irrational number. We have studied in grade 9, and yesterday also we have discussed the great Indian mathematician Aryabhatta and Ramanujan and their contribution towards the decimal representation of pi. Yesterday we have discussed in detail the example 1 and the exercise 12.1 in our lower classes. We have already came across the terms sector and segment. Sector is the portion of a circle enclosed by two radii and the corresponding arc, whereas the segment is the portion or the part of a circle which is enclosed by one chord and the corresponding arc. So area of sector and a segment of a circle. So if we have any circle with a center O and we have two radius, O is the center, let A is the point on the boundary of a circle, then OA is one radii and let B is the another point here, so B is the another radius of the circle. So here the reason AOB is the angle here, and the portion, this shaded portion, now we have two portions, one is shaded and another is unshaded portion. Both the region are called your sector. Minor sector, shaded area is minor sector, and major sector. So in a sector is the portion of a circle which is enclosed by two radii and the corresponding arc. So this is also for the major sector, the portion or the region of the circle which is enclosed by two radii OA, OB and the corresponding arc. Similarly, segment, for segment, when we divide a circle by a chord AB, then the smaller portion of a circle is called the minor segment. This is the minor part and this is the major segment. Major segment. So, my dear students, let's discuss about their area. So, how to write the major and minor? Let's take a point P here. Now, we have the area OAPB. Again here, we have the area APB. Let's take one more point Q here, or in this circle, let's take one more point Q here. So we have one more area OBQA. So the area of sector is equal to area of a sector is equal to, we know the area of a circle is pi r square, and at the center the angle subtended, if we are talking about any circle, its area is pi r square, and at the center the complete angle is 360. So if we are going for a unitary method, if in this case the angle here is theta, let's suppose this angle is theta and r is the radius. So the area of the complete circle is pi r square. So the portion by unitary method for the degree measure, 1 degree measure, the area enclosed is pi r square divided by 360, unitary method for 1. So for if angle subtended is theta here, so the area enclosed is theta upon 360 into pi r square, whereas the length of the arc, this APB, I am denoting arc in this way, is always equal to theta upon 360 into 2 pi r. So I hope you are very much clear with the length of the arc. Here we have again two arc. One is the minor arc APB. So the length of this minor arc APB is theta. This angle here is theta. So theta upon 360 into 2 pi r. And area of this portion, which is called sector, minor sector, that is theta upon 360 into pi r square. Now, if we have to find the area of AOBQ or OBQA, means major sector, the area of major sector is equal to area of the circle, that is pi r square minus area of minor sector. So here it is very important, if this angle is theta, then this remaining angle is 360 minus theta. We can apply the direct formula for major sector also, that this complete angle here, angle AOB the reflex angle upon 360 into 2 pi r. In any method we can find. We can also find the area of major sector is equal to area of circle, area of a complete circle minus area of this shaded portion, that is the sector, minor sector. Now come to the segment. If O is the center of this circle and we are interested here to find the area of the segments, minor and major segments, so in this case we have to find first the area of sector. In case of segment we have to find the area of sector. Here sector is again OAPB, and this sector is now divided in two parts. One is the segment and one is the triangle AOB. Now area of the segment, minor segment, is equal to area of a sector minus area of triangle AOB. Similarly, if we want to find the area of the segment, major segment, that is equal to pi r square minus area of the complete circle minus area of the minor segment, So my dear students, please note that whenever in book or question paper segment or sector is given, it means minor. We are talking about minor segment or minor sector, unless or otherwise it is said. For major, the word major is used. So whenever a sector or segment is written, we always proceed with the minor sector or segment. So here let's again recapitulate the concept, the area of sector and segment. What is the sector? Sector is the portion enclosed by the two radii and the corresponding arc. So we have a minor sector and a major sector. If this angle subtended by two radii is theta, and we have to find the area of the sector, so area of a sector is equal to theta upon 360 into pi r square. And if we have to find the length of this arc APB or AQB, then the formula is theta, angle theta or 360 minus theta into 2 pi r, because the complete distance, the boundary, the circumference of circle is 2 pi r. So this is for sector. Now for segment, if we have to find the area of the segment, we have to find the area of sector first. So area of the minor segment is equal to area of the sector minus area of triangle AOB. So we will move ahead with the example number 2 and exercise 12.2. And here we have to apply our acquired knowledge to find the area of a triangle AOB. In some of the cases, it is given whenever this angle is given 60 degree. When this angle is 60, most of the cases here in our book, this angle is given 60 degree. If this angle is 60 degree, it is evident that this triangle will be a equilateral triangle. How? because these two sides are a radius, means it is now isosceles triangle. So these both angles must be of same measure. We have studied in lower classes. And if these both angles are equal, so we have only one option, that both these angles must be 60 degree and 60. So this is the equilateral triangle, and we know the area of equilateral triangle is, the formula is under root 3 upon 4 a square. That is under root 3 upon 4 r square, where r, in case the side of triangle is r. If it is equilateral, all sides OA, AB and OB are of equal length. In some of the examples, we have to apply the properties of a circle to find the area of this triangle. We have to, in some of the cases, we have to apply the knowledge of trigonometry. So let's start with the example number 2. Example number 2, chapter 12. Example 2, chapter 12. Example 2 statement says that find the area of sector. It is then sector. Sector means minor. Find the area of a sector of a circle of a radius 4 centimeter of angle 30 degree. And the second part, also find the area of corresponding major sector. So we have two parts. One, if we have one circle, in this circle, if the angle subtended here is of 30 degree and radius is of 4 centimeter. So here, how to find this shaded area? First, the sector. Sector means minor sector. So here, area of the minor sector, area of minor sector is equal to theta is 30 degree, theta upon 360 into pi. In example 1, they are saying use pi is equal to 3.14. It is given in the example number 2 that use pi value is 3.14. So we will move ahead with the value 3.14 and r is 4. So r square is 16. So this is the area of minor sector. So we will go for the calculation, that is 3.14 into 16. So again we can divide here, that is 4 4s are 16, 4 3s are, and here we have 4 16 5 and we have 12.56 divided by 3. So it is near about, if we are going for the division, the area of the minor sector is 4.3 1s are 3 1 8 6, or approximately we can go ahead with 4.19 centimeters square. So area of this shaded portion, or in fact the sector, means minor sector, that is 4.9 centimeters square. Now the second part of the question is to find the area of major sector. So we can find in two ways. Now the remaining angle is 330. What is the remaining angle? That is 330 degree. 360 minus 30 is 330. So we can put the value 330 upon 360 into pi r square. And the another way we can find the area of the complete circle minus area of the minor segment or sector, minor sector. So area of the measures, that unshaded area, is equal to area of the complete circle minus area of the minor sector. So here again we have to take value 3.14. R is 4 into 4. So we have to go for this calculation first, and area of the minor sector is 4.19. So here let's move ahead with it is 4, 16, 5, and again already we have this calculation 1, 2, 5, 6, and again with 4, that is the area of the circle, that is 24, 20, 22, 8, 10, 1 carry, and 4 ones are 4 plus 1, 5. So here again decimal is here, minus 4.19. So our answer is here that it is, when we subtract from 14 minus 9, that is 5, 11, 1, that is 0, and here already that is 46.05 centimeter square. So we have the area of the major, that is 46.05 centimeter square. So this is all about example number 2. So dear students, I hope now you are very much clear with the area of the sector. In some of the questions they may ask the length of the arc. So length of the arc is again theta upon 360 into 2 pi r. So it is a very simple, and for the segment we have to find the first area of the sector, then we have to subtract the area of a triangle. So let's recap what we have discussed today. We have discussed the area of a sector. Area of a sector, that is minor sector, is theta upon, if this angle subtended is theta, upon 360 into pi r square. And this is the angle of the sector. Angle AOB is called angle of sector, and the angle of the major sector is equal to angle of major sector, that is equal to 360 minus angle AOB. Like in this case, this angle is 330 degree. Similarly, the length of the arc, length of arc is equal to theta upon 360 into 2 pi r. And area of the segment, we have studied the area of the segment. We have to find first the area of this sector, OAPB. We have to find the area of the sector, and let's join AB. Let AB is the chord here. AB is the chord. To find this shaded area, we have to find the area of sector, and from this area of sector we have to subtract the area of this triangle. So dear students, area of segment is equal to, segment means minor segment, area of a sector minus area of this triangle. Similarly, we can go for the area of major segment. Area of a major segment is equal to the complete area of the circle, that is pi r square, minus area of this segment APB. So I hope you are very much clear with the area of sector and area of segment. So you can proceed with one more example, that is example number 3, and exercise 12.2. So dear students, you have in the first week of May your periodic test 1, and the prescribed syllabus is chapter number 10, that is circle. So let's revise the chapter, the syllabus for periodic test 1, that is circle. For PT1, syllabus is circle. Periodic test 1, chapter 10, circle. We have discussed in grade 9 in detail the properties of a circle. Here, in fact, we can give name to this chapter as tangent to a circle. Chapter 10 in grade 10 specifically deals with tangent to a circle. So we have discussed in detail what is a tangent and what is secant to a circle. Tangent and secant. Secant and tangent to a circle. So secant, any line which divides a circle in two parts is called secant. And a tangent is a special case of a secant. If we have a circle here, and in this circle, if any line which divides the circle in two parts, minus segment and the major segment, this line L is called secant to a circle. And the tangent is the special case of a secant. When if we draw a parallel line, if we go on drawing a parallel line in this way, so at one point these all lines intersect the circle at 2 points, but we will get at least one point here P. From that point we have one line which intersect a circle at one point here, and if one more point, if we go on drawing a parallel lines, then we will find one more line here at point Q that is also touching or intersect at a point. So tangent is a when, if this is the line L, if I am bringing this line here which is just touching a circle at a point, a single point, is called tangent to a circle. So we have the different cases. We have center of a circle O, and where this point P, or where this line just touches the circle, this point is called point of contact. Where the line touches the circle, this is called the point of contact. For example, if again take a one circle here, and let's draw a line which just touches the circle at a point P. This point P is called the point of contact, and this line is the tangent to a circle. So we have in total 3 cases with the circle and the line. Case 1, any point inside the circle, if we take any point inside the circle, then there can be any tangent from that point. So in first case, the answer is no. We don't have any tangent, means if any point inside the circle, from any point inside the circle there cannot be any tangent, or no tangent passes through the or any point which is inside the circle. So first case, when any point inside the circle, any point inside the circle, no tangent. Case 2, on the point, on the boundary, if any point on the boundary of a or on the circumference, there will be one and only one tangent which can pass through that point. If any point is here, any point, if we draw a line which is just touching that point, we can have only and only one line. We have done the activity also in the chapter. Now the case 2, on a circle or any point on the circle, any point on a circle, there will be one and only one tangent, only one tangent to a circle. And whereas the case 3, any point outside the circle, if we have a circle and we have any point outside the circle, we have already done in the construction, we can have a pair of tangents. Let this point is P, here it is touches at point A and it is touches at point B. So we have, this is the third case. Case 1, when any point inside the circle, we don't have any tangent. Case 2, any point on the boundary or any point on the circle, its circumference, we have only one tangent from that point. And point P is called point of contact. Case 3, we have a pair of tangents from any external point. Any external point means any point outside the circle, we can have a pair of tangents. Like here, PA and PB are the two pair of tangents. So we have in this chapter, this is a very small chapter in grade 10. We have so many easy chapters, and chapter circle is one of the easiest one. It is having two theorems 10.1 and 10.2, 3 examples, example 1, 2 and 3, they are very important, and 13 questions in the exercise. 10.1 exercise is simple fill-ups and MCQ types. 10.2 exercise, only 13 questions and all are easy and important one. So let's discuss today in the revision both the theorems. What is the statement of first theorem? First theorem says that if we join O with P to the point of contact, any circle, if here A is the point of contact and AP is the tangent, always this AP and AO makes a 90-degree angle. How to prove it? That this angle, let here this is a Q point, we have to prove, that is theorem 10.1, that OP's also known as normal here. Here PQ is the tangent, OP is a normal at a point P, normal of a circle at a point P. So it's very simple. If I am joining O with Q, up to here this is equal. OP and this shaded line, these are both of same length because both are the radius. But I am joining O with the Q. So we have OP is always less than OQ. Now, not only Q, we can choose any point on this line other than P. Okay, P is the point on the circle also and on this line. If I am choosing any point here, P, Q, R, S, T, any point on this line, then always we have OP distance, that is the radius. The radius of this circle is always less than this line segment OQ. Or in other way, we can say that this radius of this circle is always of shortest length. If I am joining O with R or any point here, all these points except OP, all are of greater length. So in physics we have studied the shortest length, the shortest. If I am just removing this pen, it will take the shortest, it will take the shortest distance, and shortest distance is the perpendicular distance. So this is the simple logic here. Sometimes 1 or 2 marks question is asked. This is the logic and it is given in the book. That is theorem 10.1. Now the most important theorem, that is 10-point theorem 10.2. Statement of 10.2 theorem says that always the length of the pair of tangents is always equal. Or sometimes question is asked, prove that the length of the pair of tangents is always equal. So it is asked sometimes 3 marks. Or sometimes statement is given and so join O with P. We want to prove here, you can write down the statement of the theorem. It says that the length of the pair of tangents is always equal. So we want to prove here, to prove that AP is equal to BP. We want to prove that length of pair of tangents is always equal. So here let's join O with P. We know by theorem 10.1 that these two angles, angle OAP and OBP, both are of 90 degree. So in triangle, how to prove? In triangle AOP and triangle BOP, here OA is equal to OB, logic, radius of the circle. OP is equal to OP, both triangles this side is common, whereas angle OAP is always equal to angle OBP, both because both are right angle. Theorem 10.1 says. So therefore triangle AOP is congruent to triangle BOP. So here this logic is, the reason is very important, and I am talking about here congruency, congruent. Triangles are congruent. By which rule? Right angle the side opposite to the right angle, that is OP. For B also, that is OP is the opposite side, that is the hypotenuse, and the other side, that OA and OB are the sides. So here we have, by RHS rule of congruency, both triangles are congruent, and by CPCT, corresponding parts of congruent triangle says that AP is equal to BP. So this is all about our theorem 10.1 and 10.2. So regularly we will go for the revision. We will take a few concepts, questions, examples from chapter number 10. And dear students, this is a very, very easy chapter, circle, and it is totally based on secants and tangent. So that's why I have already discussed with you its name, because circle, the main property of a circle we have studied in grade 9, grade 10, and we can even name it as tangent to a circles or tangents to a circle. So complete the topic sector area related to the circle, that is sector and segments. Try to solve exercise 12.2, and for PT1 go on revising chapter circle. I'm again saying this is very, very easy chapter, so work hard. Thank you very much.